Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Cagey Doppelgängers by Fenners. And here are the rules. We have normal 9 by 9 Sudoku rules apply, which means place a single digit from 1 through 9 in every cell in the grid such that there are no repeats in any row, column, or designated 9-cell region, in this case a box. We have digits cannot repeat along a marked negative diagonal. So you cannot have repeats along the diagonal either here, this specific diagonal. We have quadruples where digits in circles must appear in at least one of the 4 surrounding cells. So, for example, this quadruple says there must be a 5, a 6, and a 9 in the 4 cells surrounding it. And that's how quadruples work. And finally, we have cages, where cages are either killer cages, where the digits do not repeat and sum to the clue, or look and say cages, where the clue indicates how many times the digit appears in a cage. For example, that is, I would say this should be an for example, exempli grazie, which is e.g. A 4, 1, 4 means there is 1 4 in the cage. Digits can repeat in look and say cages. So cages are either killer cages, in which case this would be, these two digits would add up to 14. So you would know if this is 5, this would be 9, assuming this is the killer cage. Or it's a look and say cage, in which case this has 1 4 here, which is 4, right? This 2 4 would be 20, it either adds up to 24 without repeats, or it's a look and say cage, which has 2 4s. Right? Because it's 2, 4. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So we know in this cage, this must be 5, 6, and 9 here, which means 5, 6, and 9 cannot be any of these. If it adds up to 24, it must have 7, 8, and 9 there. So this would be 7, 8, and this would be 9. Or this would be 7, 8, and this would be 9. If it's a look and say cage, it has 2 4s, but they're only within 3 boxes. So there's no way you can have both of them be look and say cages. So one of them has to be a look and say cage. And you cannot have 2 killer cages, because they all require 7, 8, 9, and therefore, if they were both killer cages, all of these would be 7, 8, and 9, but that's 3 digits in 4 cages, which is not allowed. So one of them is a killer cage, and the other one is a look and say cage. So that means 4 has to be one of these 2, and then the other 4 has to be either here or here. So 4 cannot appear in the rest of this box. We also are in this central box. 7 and 8 cannot appear in the rest of this box either. And we know this is 5, 6, or 9 here. This cannot contain 5, 6, 9, 4, 7, or 8. So this must be 1, 2, or 3 specifically. What does that mean? So similarly here, you can't have 2 cages adding up with 3 unique digits adding up to 24, because these 4 cells would require 3 digits, which is not allowed. So one of them has to at least be a look and say cage. And if we try to make both of them look and say cages, they're 2 4s in 3 boxes. And there are never 4 4s total in 2 boxes. So that's not allowed. So this has to be a combination of 7, 8, or 9. So 7 cannot be either of these. 7 could be either of these. And we have a 4 having to be one of these 4 cells. But we don't know. So this would either have a 7, 8, 9 here, or it's a 4. And this is also 7, 8, 9, or it's a 4. Oh, that's interesting. Huh. What does that mean? Well, it's very interesting. Okay, so either this is 4, and this is 7, 8, 9, or this is 4, and this is 7, 8, 9. If this is 4, that means both of these cannot add up to, cannot have a look and say 1, 4, right? Because this is 4. So this must be 5, 6, 8, 9 here, if that's the case. If that same thing with these, right? So these are actually symmetric around the negative diagonal here. So whatever works for one area also works for the other area. It has to, right? If, okay, this can never be 4. If this were 4, the problem is you need 2 4s in the look and say cage. And if this was 4, it would eliminate 4s in both of these places if that's the case. So this can never be 4. Actually, it's the same here. This can never be 4 because that eliminates 4 from being in both cages. So this can never be 4. The thing is, these could be any other digit if it's in the look and say cage. So we don't know. Same here, right? What are we given then? So if this is 4, let's say it's not 4. Say it's 7, 8, 9. These could still be both killer cages. We don't actually know if one of them is a look and say cage. At least one of them is a killer cage. We don't know if both of them are killer cages, right? This cannot be 2 4s, so this must be a killer cage adding up to 24. 7, 8, 9. Can this ever have 3 4s? The answer there is no, right? Because we know one of these cages is a look and say cage, which contains a 4. So either 4 is here or 4 is here. To have 3 4s here, it has to be 4 here and 4 here and 4 in here. But that would force both of these to be 9, which would force these not to be look and say cages, which would mean all of these would have to be 7 and 8, which is not allowed. So this has to add up to 34 specifically. And it must be... these are the digits 1 through 6 here. So that's at least 20. It's at most 20. Can you have a 6 here is kind of the question. This would be 15, and then these two would add up to 34 minus 15, which is 19. So no, 6 cannot be here. 5 cannot be there for the same reasoning, because if you have 1, 2, 3, 4, 6, that adds up to 16. 34 minus 16 is 18, and 2 unique digits can never add up to 18. So this is 1, 2, 3, or 4. So if 4 is here, this would be 1, 2, 3, 5, 6, which adds up to 18 or 17, and then these two would add up to 17, so it could be 8 and 9, and 8 and 9. So if that's 4, this is 1, 2, 3, 5, 6. If this is 3, this is 1, 2, 4, 5, 6, which is 18, so this must add up to 16, which would be 7 and 9. If this is 2, that's interesting. Could this be 2? That would mean this is 1, 3, 4, 5, and 6. That's 19. So the remaining two digits would have to add up to 15. 34 minus 19 is 15. And it could be 7 and 8. Obviously, it could not be 6 and 9 because we already have a 6 in this. So this has to contain 5 and 6, which means this cannot be 5 and 6 here. Can this ever be 1? If this is 1, this becomes 2, 3, 4, 5, 6, which is 20, plus 2 digits, which have to add up to 34 minus 20, which is 14. That would be 5, 9, or 6, 8, but we already have a 5 and a 6 here, so this cannot be 1. So we know 1, 5, and 6 have to be these cells, which means this cannot be 1, 5, or 6, which means in this quad, these digits must specifically be 1, 5, 6. The rest of this box has to be 2, 3, 4, 7, 8, 9. This obviously can't be 7, 8, 9 because of the 7, 8, 9 triplets in the row. These also have to be 1 through 6. This specifically is 4 or 9. This specifically is 4. Oh, this can't be 4. If this is 4, that would force both of these to be 9, and therefore that would force both of these to be 7, 8 pairs, and that's not allowed. So this can't be 4 here. Therefore, what we do know then is that this is either 1, 3, 4, 5, 6, or 1, 2, 4, 5, 6. If it's 1, 2, 4, 5, 6, that adds up to 18. So the rest, this must be 7 and 9. If it's 1, 3, 4, 5, 6, that adds up to 19. So this must add up to 15. So it's 7 and 8. Either way, 7 has to be one of these two digits. Which means this can never be 7. So this is 8 or 9. Oh, that's interesting. In this negative diagonal, where is a 7 possible? 7 can no longer be here because one of these two is 7, so that eliminates 7 here. So 7 has to be one of these two, which means 7 can't be here. One of these needs to be 7, 8 with 9. And since 9 cannot be here, this must be 7 or 8. This must be 7 or 8, which means 7 cannot be on the diagonal, which means 7 has to be on the diagonal here. So this cannot be 7 here. Therefore, this must be 4 or 7 exactly as possibilities here. 8 has to be in a 24 cage, in the killer cage. Because again, you can't have 2 look and say cages here with 2 4s and then another 2 4s, because that's 4 4s in 3 boxes, which is not allowed. So 8 has to be in one of these killer cages, which means 8 cannot be on the diagonal here. 8 cannot be on the diagonal here because it must be in the killer cage 24 with the 7 to add up to 24 with the 9 outside the cage, because the 9 has to be in this quad in box 5. So 8 cannot be here. Therefore, this must be 8, which means this can't be 8, this can't be 8, these can't be 8. This is a 7, 9 adding up with these digits to add up to 34. Well, 34 minus 16 is 18. So this must be 1, 2, 4, 5, 6, which makes this a 3. So this is 3, which means this cannot be 3. These are not 3. This is a 1, 2, 4, 5, 6 quadruplet, or quintuplet, sorry. So that's 18, which 16 adds up to 34. 3 cannot be here. 3 cannot be on this diagonal. What else do we know? So either this is 4 or it's 8 and 9. These can be still 1, 2, 3, 5, 6, 7. That's pretty broad. This is 4 or 7. 4 or 7. This could be any digit that's not 5 or 6. 1, 2, 3. And not 4, 7. It could be 7 or 8, obviously. So no 4, 5, 6, or 9. So this is 1, 2, 3. This is either 4 or it's 7, 8. And this is 4 or 9. Okay. Because this is now at just a 7, you could still have both of these be 14 killer cages. Hmm. Hmm. 3 in... Okay, so 3 in box 7 has to be in the squad. Cannot be here, so 3 has to be here. So 3 cannot be here. Where is the 3 in box 8? It has to be here. So this is 3, which eliminates 3 here. Does that tell us anything? Not particularly. Five has to be one of these 4. Or sorry, one of these 3 specifically. Hmm. Okay. Okay. If this is 4, say this was 4. That means this is 7, 8, 9. So this is 4 and 4 here. So if this is 4, that means this cannot be 4 here, right? Because the 4 would have to be these two. And 4 cannot be here. 4 cannot be here or here. So this would have to have 1, 4. If this were 4, this would be 7, 8, 9. This would be 4 and 4. 4 cannot be here, 4 cannot be here, and 4 cannot be here. So this would be 1, 4. So it's guaranteed one of these is a 1, 4 here, right? That means if this is 4, this can never be 4, right? Because if this is 4, this is also 4. That 4 eliminates 4 here. So this is 7, 8, 9. This becomes 4 and 4. So I think one of these two must be a 4. One of these two must be a 4, which eliminates 4 in the rest of the row and the rest of the column. Also, if this is 4, that makes both of these 4. This is 4, that forces that to be 4, so none of these are 4. So this has to be a killer cage no matter what. 5, 6, 8, 9. If this were... One of these is 5 or 6. So this cannot be both 5 and 6, which would force this not to be 1. So this can't be 1 here. One of these is a 1. We're not sure which. If this is 1, 4, then this becomes 7, 8, 7, 8. This is 9. This is 7. This has to be 9. Obviously, that works. Can you ever have a 9 in one of these? If this is 9, that makes this 4 and this 7. But that would force this to be 9 and 9, which is not possible. So 9 cannot be outside. 9 has to be one of these two digits here in box 8 and has to be one of these two digits in box 6. Okay. Yeah. The rest, okay, so since one of these is 5 or 6, one of these is 5 or 6, the rest of column 5 cannot contain 5 or 6. And this quad has to have 5 or 6 around it. So it cannot be these two. These must be a 5-6 pair. This then must be 9, which eliminates 9 from being here. This has to be a 6-8 pair to add up to 14. That eliminates 8 from here and 6 from here. So this is a 1-5 pair, which eliminates 1 and 5 in the rest of the box. So this must be 6 here, which means 6 cannot be here. So 6 is either here or here. This is either 5, 9, or it's 4 with a whole bunch of possibilities. This is 5 or 6, and one of these two is 5 or 6. So the rest of the row cannot contain 5 or 6 in it. Okay. These can't be 7, because we know 7 has to be on the diagonal, because we're missing 7 somewhere on the diagonal here. So this digit can never be 7. If this were 7, that would force us to be 4, but then this has to be 7, 8. So that can't work. So this has to be 7 if this is 8. What's on the diagonal? So this is 9 with 1, 2. Okay. This can't be 8 because of the 8, 6, 8 pair in the column. 5, 6 here. The rest of column 5 has to be 2, 3, 4, 7, 9. Obviously, 9 cannot be here because one of these two is a 9. This can't be 3 because of 3 in the diagonal. This cannot be 7 because of 7 has to be with the 7, 8 in the killer cage. Where is the 9 in this negative diagonal? One of these negative diagonals must be 8 and 9, because 8 and 9 cannot be here, 8 and 9 cannot be here. Because 7 had to be on this diagonal, this had to be 8 and 9, 8 and 9 here. So 8 and 9 cannot be on the diagonal here, which is why we knew this was 8, because 8 couldn't be anywhere here. 9 has to be here then. So this can't be 9 here. That leaves, we have 7, and then 1, 2, 4, 5, 6. And this is obviously 7. 4 cannot be any of the digits here, because 4 has to be in the look and say cage, 2, 4. So 4 cannot be any of these. 4 cannot be any of these. 4 can't be here either because it's in the look and say cage. Therefore, where is the 4 in the negative diagonal? It has to be here. So this is 4, which means 4 cannot be here, 4 cannot be here, 4 can't be here. So in box 8, where is the 4? It must be one of these 3 cells, which means in box 7, it has to be one of those 3 cells. And this is 1, 2, 4, 5, 6, cannot be 5. So 4 has to be one of these. Cannot be 5 because the 5 has in the box has to be around the quad. Can this actually ever be 4? I think so. Yeah, any of those could be 4. You cannot have 5 or 6 here. This 9 actually eliminates 5 and 9 here. So the 6-8 pair eliminates 6 and 8 in the rest of the row. This can't be 6. This is 5, which makes that 6. So none of these can be 6. This can't be 8. So this becomes a 4-7 pair in box 5, which eliminates 4 and 7 in the rest of the box. We know 3 has to be one of these 2 digits here. So this cannot be 3 here. 8 is one of these 2, but we're not sure which. 7 obviously is one of those 2. Again, I don't think this can ever be 7. Say this was 7, that makes this 9, which makes this 4. Well, okay, if this is 7, obviously this can't be 7. If this is 9, this becomes 4 and 4, which makes this 7. And so this can never be 7 here. It could be 8, though. If this is 7 if this is 7 here, that makes this 4 and 4. This would be 7, 8, so this could be 8. So where is the 6 in row 6? It has to be one of these 2. This can't be 6. The rest of row 5 is 1, 2, 3, 4, 7. But this can't be 4. Because if either this is 4 or this is 7, 8, 9, which forces this to be 4, so this couldn't be 4. Can this ever be 4? If this is not... Okay, so say this was 4. That would force this to be 7, 8, 9, which would force this to be 4 and 4. So no, this can't be 4. So same reasoning there, right? Right, because if this is 4, that makes this 7, 8, 9, because it can't have 2 4s. Then this becomes 2 4s, and that eliminates 4 there. Right, we just know 4 cannot be any of these, so... Actually, 4 has to be either here or in the 1, 4 area. Therefore, where's the 5? The 5 has to be in box 2, one of these 3 cells. We also know where is the 5 on the negative diagonal. It has to be on in one of these cells because it can't be here. Can't be here. So these cannot be 5 here. We don't know what they are, but... Oh, but this could be 5 and 9 here. Right. Uh, hmm. If this is well, no, okay. If it's 1, 4, this becomes 7, and that's 9. That's fine. I'm guessing it has to use this or this quad to make it not quite work. Or not be completely symmetrical, obviously. Because we have a 6, 8, 6, 8. Obviously, that's... one of these is 5, 9. Oh! No, that doesn't work. That could be 5 and that's 9. That's fine. If this is 5, 9, obviously this is 9, 7, 8. 4, 4. This is 1, 4. So this would be 7. Can this ever be 7? I don't think so, right? If this is 7, this becomes... Oh, yeah, it could be. Never mind. So 4 is one of these two. In column 5. Does that tell us anything? Not particularly. Hmm. This cannot be 3 because of the 3 in the row. This can't be 3, so 3 has to be in box 6, one of those 3 digits there. In box 4, it's one of these 4 digits there. What are the remaining digits in column 4? 1, 2, 4, 7, 8, 9. Obviously no 8. No 4. I don't think you could have a 7 either, right? Say this was 7. That forces us to be 4 and 4. Which means this is 5, 9. which forces this to be 7, 4. This is 7, 8, and 9. Actually, it could be 7 here. Huh. 8 is either here or here. If this is 7, that makes this 4 and 9. But this 7 would eliminate 7 here, so that would be 9. So this can never be 7. This is 2 or 8. Okay. Not sure what that says. Or what that means. Well, it does mean in column 4, where is a 7? It has to be one of these 3 cells. So this can never be a 7. This is a 2, 3. So we have a 2, 3, 2, 3 pair in column 5, which eliminates 2 and 3 in the rest of the column. This is now 4, 7. We have a 4, 7, 9 triplet now in box 8, which eliminates 4, 7, and 9 in the rest of that box. We have a 2, 8, 2, 8 pair here. What are the remaining digits in column 5 or 6? There's a lot of them. It could be 1, 2, 3, 4, 5, 7, 9. 7 cannot be there because one of these 3 is a 7. Right, because we tried to make, these can't be 7 because it would have to have 7, 8, and 9. 9 would have to be here. 8 would have to be here because 8 cannot be here. 9 cannot be either of these. We tried to have a 7 here. That forces this to be 4, which forces this to be 9. And this 7 will eliminate 7 here, so this would both be 9, and that would not be allowed. So 7 has to be one of these 3. Five has to be one of these 3. This can't be 4 because of the 4 in the column. Five again has to be one of these 3. 1 cannot be here because 1 is around the quad circle here. Interesting. So if 1 is in these 2 cells, that means this is 1, 7. This is 5. This would have to be a 2 in that case. So this would be 2, 3, which would make this 2. So 2 could not be any of these. 3 could not be any of these. It would be a 1, 8 pair. 2 could not be... This, again, this was assuming this was 1, 7. So this would be 1, 7. This would be 5. 2 would be here. 2 cannot be any of these or here. So this would be 8, which would make this 2. This 8 would eliminate 8 here, so that's 1. This would have to be double 4s, so it's 4, 4. This would be 7, 8, and 9. That would make this 4. This 9 would make that a 7, which would make that a 9. This would have to be 5 and 9 here, which would force this to be 3. This 5, 9 pair would eliminate 9 here. That would be a 1-7 pair, which eliminates 7 here. So this would be 4. This would be 4. This would have to be 7 with 8 and 9. This would be a 1-7 pair. Couldn't be 1, obviously. Couldn't be 8 or 9. 4 could not be either of these. So far this is looking fine. This has to be 1-4 here. This couldn't be 4. You have 1-6 here, and this would be 2, 3, and 6. This couldn't be 1, 2, or 3. It's 4, 5, and 6 here. This can't be 4 here or here, so this would be 4, which means this could not be 4. You couldn't have 5, 6 here either. Whereas the 6 in column 9, it would be here. So far, this is looking fine. This is 5. We have 2, 8, 9 remaining. 8 cannot be either of these, so 8 would be here. This would be a 2, 9 pair here, which eliminates 2 here. So far, this is looking fine. 5 would have to be one of these two because of the 3, 5 quad. So this would have to be 5 here, which would mean this is a... well, we don't know. 4 obviously would be here. We'd have 1... it can't be 7. Cannot be 7. So it'd be 4 with 1 or 3 here. So far, it's looking fine. Where would the 6 be? It could be either of these. This can't be 6. This can't be 6. So far, okay, this 5 eliminates 5 here, so this would be 9, this would be 5. 9 would be here, which makes this 7, this is 9. So 9 could not be here, 9 would have to be here. 8 would have to be here, which makes this 6 and 8, so 6 could not be here. This is all looking fine. 8 could not be here or here, it must be here. Then in column 3. Three is here, 5 is here. This 2 eliminates 2 here, so it's a 1-5 pair, which eliminates 5 here. That would force this to be 5, which means this could not be 5. Therefore, one of these two would be 5, so this couldn't be 5. This is 6, which makes that 5. Therefore, this can't be 6, so this would be 6 here, which means 3 would have to be one of these two digits here, which means this is 1. This would not be 1. So far, this is looking fine. This is 1. This is 5, 2. This is 7. This 2 eliminates 2 here, so it's 1, which makes this 2, 7, and 2, 7. This 5 eliminates 5 here, so this is 1. This becomes a 3, 9 pair. That 3, 9 pair eliminates has to be in columns 1 and 2. These can't be 2. This can't be 1. This is 5. This is all looking fine. Yeah, this is probably not the way to go about it, then. Not sure if there's a more elegant way to look at this, unfortunately. Okay. So then, can this ever be 1 here is kind of a question, right? Because it looked like the 2 was fine. Hmm. What happens if we make this 1? Then this becomes 2, 5, 7. This has to be 1 with 8 or 9 here. This can't be 1. This can't be 1. None of these could be 1. Therefore, 1 has to be one of these two. Which doesn't tell us very much. This has to be a 3-6 pair. Which means 6 has to be here. So 6 cannot be here. I mean, it seems fine. 1 cannot be here. 1 is one of these two. So which one then was that? I think the 5, 9 was here if we had a 1, 7 here. That became 2, 3, 2. I don't remember. Oh, because if this is 1, 7, that became 2, which would force this to be 8. So this could not be 7, 8. This would have to be 4 and 4. Which means this couldn't be 4, so this was 4, this was 5, 9. So what happens if we assume this is a 4 here? Okay, this can't ever be 4. Because if that were 4, that would make this 7. This would be 5, 9. This 4 would make this 7, 8, 9 then. So this would be 4 and that would be 4. And that's not allowed. Right. So assume this is a 4, which makes this then 7, 8, 9. That 8 eliminates 8 here, so that's 2, which makes this 1. None of these could be 1. So this is 2, 5, 7 triplet, which eliminates 2, 5, and 7 in the rest of the box. Also, 1 has to be in this quad, so it has to be with the 1, 8, 9. So this is 3, 6. This is 4, and this is 4, which makes this 7. This is 8. This can't be 1 or 8, so this is 2, which makes this 3, which makes that 2. So 2 could not be here or here. This 4 eliminates 4 here, so this is 7. And we have a contradiction. No, we don't. This would not necessarily. This is not 7. This 7 eliminates 7 here, so this is a 7 here. This cannot be 7. This can't be 7. And these can't be 7. This is 7, 8, and 9. Which eliminates 7, 8, and 9 in the rest of the box. Therefore, this can't be 8 or 9. This is 1. This is 4. This is 4. This has to be a 5, 9 pair. So far it's looking fine. This can't be 1 or 9 here, or 2. So this is a 3, 4, 5 triplet. 7 eliminates 7 here, so this is 9, which makes this 7. Where is the 7 in row 4? Cannot be here because of 7 in the box. These are filled out. This can't be 7 because 7 in the column, so this is 7. 4 cannot be here, and 6 cannot be here because we have 2 4s in column 1 and 2, and we have 2 6s in columns 1 and 2. So this becomes a 1-2 pair, which eliminates 1 and 2 in the rest of the row and box. This 1-2 pair also eliminates 1 and 2 here. So this can't be 1. This is 5. This can't be 1, 2, or 5. This is 6, which makes this 4. Therefore, 6 has to be here. This has to be a 1, 2, 3 triplet here. So this is 1 or 2. This is 1, 2, 3. This is 1, 2, or 5. 5 has to be one of these. So this must be a 6. This can't be 1 or 2, so this must be 3, which means this can't be 3. This is a 1, 2 pair. This becomes a 6, 8 pair here. So far, this is looking fine too. This has to be 5. Aha, and there's a contradiction because we need a 5 outside of this quadruple circle or quadruplet. Quadruple circle. Yeah, it's called quadruple circle. And that's a contradiction here. I don't know if I like that. That's a very convoluted way to get to the contradiction. But, I mean, it is what it is. So that's a contradiction there for assuming... What did we assume? We assumed something. I think we assumed that this was 7, 8, and 9. Right? So this can't be 7, 8, 9. This must then be 4 and 4. This cannot be 8. This then becomes 7, 8, and 9. The 7 eliminates 7 here, so it's 4. 8 eliminates 8 here, so it's 2 and 8. This can't be 2 4s, or 1 4 here. So this must be adding up to 14, which leaves us as 5, 9. That eliminates 5 and 9 in the rest of the box. This can't be 2 or 2. This becomes a 1, 7 pair, which eliminates 1 and 7 in the rest of the column. So this is 4, which makes this a double 4. This can't be 8 or 9. This is 8, 9, and 7. So this is 7. 4 can't be here. 4 can't be here. 4 has to be one of these two. So 4 cannot be either of these. This can't be 4. That can't be 4. So 4 cannot be either of these two. So this must be a 4 here. Because 4 is eliminated in that column and that column in 7 and 8 because of the 4s in the column. So this must be 4 has to be in column 9. In box 3 cannot be in row 1 and 2. So this is 4. This cannot be 4 anymore. Okay. The rest of this must be 1, cannot be 1, because 1 has to be surrounding this quad. It's 2, 3, or 6, because 5 has to be one of these 3 digits on the diagonal. Okay. Therefore, we know 6 has to be in row 3. Cannot be any of these cells. It must be one of these two. So this cannot be 6 here. Where is the 6 in column 9? It can only be here. So this is 6, which eliminates 6 here and here. Where is the 6 in row 9? It has to be one of these 3 digits here. Okay. This can't be 7 anymore, which means 7 has to be one of these 2 digits there. Oh, the 7 eliminates 7 here, so this is 9, which makes this 7, which makes that 9, and makes that 7. Okay. This 1, 7 pair eliminates 1 and 7 in the rest of the box, so this can't be 1. This is a 2, 3 pair, which eliminates 2 and 3 in the rest of the row, so this can't be 2. That leaves this as 1, 5, 6, and 7 as possibilities. Okay. Three is one of those 3. Hmm. Hmm. Where is 9 in row 4? It's either one of these. Actually, what are the remaining digits in row 4? We have 1, 2, 3, 5, 8, and 9. But 8 cannot be here. 8 cannot be here. Where is the 8? 8 has to be here. So we have 1, 2, 3, 5, 9 left. And 9 has to be one of these two. Okay. Mm. Where are 8 and 9 in column 7? Cannot be here. Can't be any of these because of the filled in 8s and 9s. Can't be here because of 8 and 9 here. Can't be here because of the 8-9 pair there, so this must be an 8-9 pair here. This is then 1, 2, 5, 6, 7. And this is 1, 2, 3, 5, 6, 7. And that's fine. 6 has to be one of these two. 8 and 9 are here. These digits are 1, 2, 3, 5, 6, 7. 6 cannot be here, though. These digits are 1 through... It cannot be 6, so it's 1 through 5 here. And 4 cannot be here. Where is the 8 in column 3? Cannot be any of these because of the 6, 8 pair. 8, 9 pair. Can't be here or here, so it must be here. So this is 8. The rest of row 7 is 1, 2, 5, and 7. This can't be 5, though, because the 5 has to be surrounding the quad. We have a 1, 2, 4, 5, 6, 7 sextuplet in box 7, which eliminates 1, 2, 4, 5, 6, 7. So this must be a 3, 9 pair here. Also, this 2 can't be 2 because of the 2 here. Where is the 9 in column 3? Cannot be here. Therefore, it must be here. So this is 9. Because this can't be 9 because of the 8-9 pair. This can't be 9 because of the 3-9 pair in the box. Okay, 7 has to be one of these two. 6 has to be one of these two. Interesting. So 5 has to be one of these two here, which means because this is a 3-9 pair. So this cannot be 5. Therefore, 5 has to be in box 9, one of these two, which eliminates 5 in the rest of the column. That doesn't give us much, unfortunately. 5 can still be either of these. 5 could be any of these 4. So 5 cannot be any of these. 5 can't be here. So 5 is one of these two. If 5 is here, that means 5 cannot be here. And then 5 would have to be here. That's fine, as long as 5 is there, then 5 is there. That's fine. If 5 is here, none of these could be 5. Therefore, this can't be 5. One of these 3 is 5, but that seems fine. Let's say... But then this would be 2 if this is 5, right? So this is 2, this is 1. So if this is 5, that means this can't be 5. So this would be 5, that would be 2, which would force this to be 1. So this would be a 2-3 pair, and that would be 1. So either this is 1 or 5 here. If this is 5, there's not as many restrictions. One of these is 1. That doesn't tell us very much. If this is 5, this becomes not 5, so this is 5 here. So if this is 5, I think this worked last time. 5, 9, 5, 8, 9. This is 6, 8. This would mean this is not 5, so this is 5. So this couldn't be 5 anymore, therefore this would have to be 5. Therefore that would be 6, which would make that 6. Yeah, I think that worked last time. What happens? So if we make this 5, this also becomes a 6. Does that change anything? This is 1, this is 5. That makes this 2, which makes this 1. This becomes a 2-3 pair. That's why this is 1. This is 2, 3, 7. So that makes this 1. This is 2, 3, 4. This would be 3 and 6. That can't be 2, 3, or 6. So this is 1. This 7 would eliminate 7 here. So it's 5 and 7. And we'd have a contradiction. Okay. So that's why this cannot be 2. So we just tried it. Oh, that's why this can't be 5, actually. Right? So this 5 makes this 5, which makes that 2. And I think, actually, that 2 there is the contradiction. Maybe? Maybe not. This is 1, 2, 3. This becomes a 1, 5 pair. Yeah, maybe it's just basically this being a 5 is a contradiction. So we know this is 5, which means this can't be 5 here. This can't be 5 here. Which means 5 is one of these 3. We can remove the 3s. That's kind of broad. So 4 has to be one of these 2, and 5 has to be one of those 3. 5 is one of these 3. So 5 works here. Does 2 being there give any contradiction? I don't think so. That makes that 1. This would be a 3, 6 pair. This would have to be 5 and 7, so this would be 1 here. Which means 1 could not be here or here. That's fine. 2 and 3, 2 and 3. 1 could not be here. This could not be 1. This couldn't be 1. This couldn't be 1. 1 couldn't be either of those, so 1's one of those two. That's fine. we'd have a 2, 3, 5, 7 quadruplet, so that would force us to be 6. Which means 6 could not be either of these. This is looking okay, too. 2 can't be here. Or here. Or here, so this is 4. That would mean this could not be 4, and this could not be 4. So this would have to be a 4 here. 3 would have to be one of these two, because 3 could not be here or here. So this could not be 3, this would be 5, which makes that 7, 5, 2, 3, 5. And we have the contradiction here. So from that, we showed this cannot be 2 here. So that is that contradiction. This has to be 5, which means this cannot be 5 here. This can't be 5 here, so this is 9, which makes that 5. 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 here, so it's 6 and 8. This can't be 5 anymore. This can't be 5 anymore, so this has to be 5 here, which makes this 6. 6 can no longer be here, so 6 has to be here. 6 can no longer be here. What else do we have? 5 can no longer be here. 5 can't be here. So where is the 5 around this quad? It has to be here. So this is 5, which eliminates 5 here, which forces this to be a 5 here. This 7 eliminates 7 here. This becomes a 1, 2 pair, which eliminates 1 and 2 in the rest of the row. This becomes a 3, 4 pair, which eliminates 3 and 4 in the rest of the box. We know in row 6, 3 and 4, 3 has to be in columns 1 and 2. In row 8, 3 has to be in columns 1 and 2. That eliminates 3 in the rest of columns 1, 3 or columns 1 and 2. So this can't be 3. This is 2. This can't be 3. This is 6. This cannot be 2 anymore, so it's a 1, 7 pair here. This can't be 1, 2, or 6. This has to be the 3. We have a 1, 2, 7 triplet in column 3, which eliminates 1, 2, and 7 for the rest of the column, so this is 6. These can't be 6. This 1, 7 pair eliminates 1, 7 on the diagonal, so this can't be 1. This is 2, which makes this 1. This 2 eliminates 2 here, so that's 3, which makes this 2. That 3, this is 1. That eliminates 1 here, so it's 2, 1, which makes a 7, 1, 1, 7. This 1 and 7 eliminate 1 and 7 here, so that's 2, which makes this 1. That makes this 5, 2. 5 eliminates 5 here, so this is 1, 5. This has to be a 1, 4 pair here. 5, 1 and 2 eliminate 1 and 2 here, so it's 7. This 6 eliminates 6 here, so it's 8 and 6. These can't be 1. This can't be 2 here, so this is 7. This can't be 1 or 3, so this is 2. This is 7. This can't be 1, 2, or 7, so this is 3. This is 1. 2 eliminates 2 here, so it's 3 and 2. 8 eliminates 8 here, so it's 9 and 8. 9 eliminates 9 here, so it's 3 and 9. 3 eliminates 3 here, so it's 4 and 3. That leaves this as 1 and this as a 4. Woo! That was, yeah. It wasn't hard. You just had to go through all the combinations to basically get to the contradictions. Yeah, I'm not sure how I feel about those. I mean, it's essentially, I don't know how else you're supposed to attack that. There doesn't seem to be a very elegant way of doing it, but I personally don't care about elegance. You know, just solving it seems fun. But a lot of people don't like about this, I forget what they call it. Basically going down one path and then basically finding the contradiction there. People don't like that. I don't know why. It's a valid way of doing it. It's obviously not as elegant as other ways, but I mean, I don't know. It's a way of solving it. And in fact, actually, if you think about it, most of solving most of the logic in these puzzles are essentially that type of thought process. It's basically what happens if I assume this value is a certain value and then go into a logical conclusion from that, right? It's just the question of how far that path is down that path, right? And this was a very long path to do it. Some people won't like that, but it is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.